So yeah, let's look at the second part of this section, the area between two curves. And so what we're gonna have here is, so if f and g are continuous functions, with f of x greater than or equal to g of x throughout a closed interval from a to b, then we can find the area. So then the area of the region between the curves from a to b, of the region between the curves from A to B is going to be equal to, and so we're going to denote it with the capital A for area, and it's going to be equal to the integral from A to B of f of x minus g of x. And you're going to integrate that with respect to x. And so let's do an example. Oh, and real quick, let me just kind of point out. So what we're looking at in this section is we're just doing the area between two curves. Okay, so but for this example, we're going to find the area of the region enclosed by the parabola y equals 2 minus x squared, and the line y equals negative x. And so to find the area, what you usually want to do is you want to either graph these things so that you can picture what's going on, especially when you're first starting out with these types of problems, right? Later on, you could probably not graph them and instead find what's called the point of intersection. But so, yeah, what I need to do is I need to figure out where these two, like what the region enclosed by these two curves is, right? And so that's what I put into Desmos. And so here, let me kind of do this and split the screen. And so here are the two curves, right? So I already graphed them. And so the red one is y equals 2 minus x squared. And then the blue one is y equals negative x, right? And so when I find the area, what are my limits of integration going to be? Where does this region start? Can you guys tell? Like, is this picture big enough? So like here, if I zoom out, yeah, -1 to 2, right? Because if I zoom out, then the only region that you see enclosed, right? So like here, this is, if I look, I can't like point on this, but if you look below this blue curve, in between the two two red sides of the parabola, right? And there's no, like, it's not enclosed, right? One side doesn't have a bound. And so the only part that's really closed off is from -1 to +2, right? And so that's where we're going to integrate from, -1 to +2. And then I'm going to do f of x minus g of x, but I haven't really specified which one of these is f and which one of these is g. So is the parabola going to be considered f or going to be considered g? Just take like a wild guess if you can't really think about it. Yeah, it's going to be f. And the reason for that is because it's the function that's sitting on top of the other function, right? So for instance, like when you subtract, you want to go from like top to bottom. And so you're going to make f of x, the function that's sitting on top of the second function, g of x. And so here, this is going to be f of x, and this is going to be g of x. And so we can make a note that f of x is the function on the top of the region. And so when we find this integral, we're going to have the integral 2 minus x squared minus negative x dx. So f of x minus g of x. And so when you simplify this, the antiderivative of 2 is 2x. The antiderivative of negative x squared is minus 1/3 x cubed. And then here, this is really plus x. And so the antiderivative of that is plus 1/2 x squared, right? And remember, you have these fractions here to undo the power rule when you take the derivative of these two things, right? And so that's the antiderivative, and then you're going to evaluate that from -1 to +2. And so when you do this, you get +9/2. So are there any questions about this problem? So real quick, let's say that I didn't have the graphs, right? Let's say I wasn't able to graph it for whatever reason. Or let's say I ask you just what the limits are or something like that, I don't know. The way you would find these limits is by finding the points of intersection, or by looking at where the two functions that you're given are equal to each other, right? Because if you look at the curve, oh, I can't bring it up that way anymore. But yeah, so if you look at the curves, right, then you see that they're equal only at the 2 points that we used as our limits, right? And so that's what we're gonna do. Oh no, that's not what I wanted. And so here, let me show you how to find the point of intersection. So points of intersection, these are often called POI. And so you just take f of x, set it equal to g of x, and solve for x. So what we're going to have here is 2 minus x squared equals negative x. This is a quadratic equation. So we're going to have to use either a quadratic formula, factoring, anything like that to solve it, right? And so when you do that, oh, you can factor this one. So this becomes x squared minus x minus 2 equals 0. And this factors as x plus 1 times x minus 2. X equals -1, x equals +2, right? So we found the same exact thing. So that's just how you would find it by hand if you didn't have the calculator or a graphing calculator for whatever reason. But since everything's online now, you guys can just use Desmos to find your limits. But so yeah, any questions about this first example? You guys ready for the next one? So yeah, I'm gonna start working on this next one. Very similar. So we're gonna find the area of the region enclosed by y equals the square root of x and y equals x minus 2. All right, so let me bring up the Desmos graphs real quick. This is the first example still. Okay, I don't know why it goes. Okay, so I guess it's gonna be on this side now. But so yeah, let me bring up example 2. All right, so yeah, here it is. So the region enclosed by y equals square root of x and y equals x minus 2. And I forgot to write part of this, and the x-axis. So if I draw this out without, oh shoot, without any like actual limits on it, we're trying to find this area. Okay, so again, we can just kind of see where the limits are, but what am I going to have to do with this problem? Right, so if I start finding the area, if I look at the actual Desmos graph, not my terrible drawing, but where do I start having the graphs intersect from? Like on the x-axis, where does like this picture kind of start? But so yeah, my upper limit is 4. And so if I'm just looking at the x-axis, then the top function on this interval is going to be the square root of x, right? And the bottom function is going to be the x-axis. But on this other interval from 2 to 4, my bottom function changes. And so what do you think I'm going to need to do to this integral from 0 to 4, right? So I know the square root of x is my top function. But then it's going to be minus g of x, where g of x depends on which interval I'm looking at. So what can I do to this integral? Yeah, you can split it into 2 separate pieces, right? So I can, if I look at this like very rudimentary drawing that I have here, then I can look at the integral from 0 to 2. And so my top function, my f of x on this interval is that square root of x minus g of x in this case is the line x equals 0, right? And so you're going to have square root of x minus 0 dx plus the integral from 2 to 4. And on this interval, g of x is the line x minus 2. And so here I had to split it into 2 separate pieces, right? And so area is equal to, if I take the antiderivative of the square root of x, so I'm going to rewrite this as x to the 1/2 dx, and then plus 2 to 4 x to the 1/2 minus x plus 2 dx. So when I take the antiderivative of this, you get 2/3, right? So 2/3 x to the 3/2. And remember, this 2/3 is canceling out that 3/2 that would come down when you take the derivative of this, right? And then you're going to evaluate that from 0 to 2. Here, again, same antiderivative, 2/3 x to the 3/2 minus, here you're going to have 1/2 x squared, and then plus 2x. Evaluate that from 2 to 4. And so here for your area, and so I'm not going to go through and do all of that, right? I trust you guys to do that. You can use this as practice. You should get 10/3 after all is said and done. And so yeah, the area of this like black region right here is 10/3. So are there any questions about this example? Okay, so do you guys have any ideas for some alternatives that I could do? So rather than splitting this into 2 separate pieces, do you see what I can change about the problem so that I'm only integrating over one piece or over one interval? So what you're gonna do is if I kind of, so here I'm gonna redraw this region that I'm looking at, right? And I'm gonna close this for now. I'll bring that back up for the next example. But so here is the region that I'm looking at. And when we integrated with respect to x, right, I couldn't look at these regions, right? Those should technically be equal because they're both width 2, but it's fine. Right, so I couldn't look at it as one whole piece because the x interval gets kind of broken up, right? The function based on where you are for x changes. And so if I were to rotate my like way of thinking about this, and so I can't really do this on my screen, right? But if I were to rotate it and instead integrate with respect to y, then I can look at this interval, right? And I can say, okay, here, the top function, oh wow, that is not straight, but the top function, which you should put the word top in quotes, right? So the top function doesn't change over the entire interval of integration if I'm integrating with respect to y, right? And so in this case, my top function would be this one, this line, while the bottom function would be the square root of x, right? And so to kind of think about why it's, when you're doing with respect to integration, it's top to bottom. When you're doing it with respect to y, it's left to right, or I mean right to left. So to kind of help you think about it or to remember it, what you can kind of think of it like is if I do subtraction on that like direction, I want to get a positive number, right? Because this is area. And so if I were to do bottom minus top, I'm going to get a negative value for my area. And that's not what I want to happen. And so, and then same way here, right? I subtract right to left to get positive numbers, right? So 3 minus 1 gets you positive 2. And so things like that. But so that's why it's going to be, so this is the top function while this is the bottom. And that's when you're integrating with respect to y. So let's redo this example. So example redone for integrating with respect to y. And so yeah, here's the picture, right? the points of intersection. So if I bring up Desmos again real quick, and I go to example 3. So notice it's the same graphs almost that I had before, except this time what I did was I solved for y in both of these cases. So you start out with y is equal to the square root of x, which means y squared equals x, and so that's the red line. And then y equals x minus 2, that becomes x equals y plus 2, and so that's the blue line. And so here, when you look at the region of integration, what you're actually going to be doing is, and so here, we don't even have to look at the x-axis, right? But I guess we can. Yeah, so there's kind of two ways we can think about it. So if we want to do it with the x-axis the same way that we were doing it in the previous example, then what are our limits of integration going to be? Where do I start seeing y values, and where do I stop seeing y values here? If I just look from the x-axis and then up. And so this is 0, this is 2. If we weren't looking at the x-axis, if instead we were looking at just the region enclosed by those two curves, then notice we could do all of that, right? We could find this region if we look from -2 all the way to +2. And so we can do two different examples here. And so I'm going to close this curve or the graphs for now. And so let's just redo the example with the x-axis first, and then I can do the second one as just another example, right? So here, you're going to have that the area is equal to the integral from 0 to 2. F of x is going to be the right function, so top goes with right, while bottom goes with left. So f of x in this case is going to be, or actually it's not even f of x, right? Because if I'm integrating with respect to y, then I want to use these two things. And so I can call this like f of y, g of y, right? But so I'm going to have the first one, which is y plus 2 minus y squared. And then I'm going to integrate that with respect to y. And so here, it's done very similarly, right? You're gonna have, or here, I'm just gonna kind of skip ahead. When you take the antiderivative of this, you're gonna get 1/2 y squared plus 2y minus 1/3 x cubed. You're gonna evaluate that from 0 to 2, and you're still gonna get 10/3. And so let me just kind of make some notes on this. So this would be like f of y, and this would be g of y. So yeah, do you guys have any questions about integrating with respect to y? Why the x? Oh, I don't know. Because I wasn't paying attention. Thank you. Is that supposed to be -1/3 y cubed? Oh yeah. Did you type that out before I changed it, Matthew? Yeah, okay. All right, so I just realized we can't do this way. And the reason is because we're still looking at y equals the square root of x. And this part right here is not in the square root of x. So we can't, like, you can't find that area technically if we use the functions that we were given in the first place. And so yeah, we're just gonna stop here. So this is the last, this is our answer.